Welcome. In this video, we'll be solving trigonometric equations involving secant part 3. Let's take a look at our example. Solve the equation given below for theta greater than or equal to 0 and less than 2 pi. Here we have the equation. Negative 2 plus secant of 2 theta is equal to negative 4. The first thing we want to do is to get the secant by itself. So let's go ahead and start off by adding 2 to both sides of the equation. That will leave us with a secant of 2 theta is equal to negative 2. The next step is to rewrite this using the definition of secant. And recall that secant is 1 over cosine. So we have 1 over cosine of 2 theta is equal to negative 2. Now, to get an equivalent equation, what we're going to do is to take the reciprocal of both sides of this previously defined equation. So the reciprocal 1 over cosine of 2 theta, it's simply cosine of 2 theta. And the reciprocal of negative 2 is negative 1/2. At this stage, we're going to introduce a new variable, namely alpha. So let alpha be equal to 2 times theta. Using this newly introduced variable, we can rewrite the previously defined equation as cosine of alpha is equal to negative 1/2. Now, in order to solve this equation, we can ask ourselves the following question. What are the angles that will have an x-coordinate corresponding to them of negative 1/2? So we take a look at the unit circle here on display, and we find the relevant angles that will have an x-coordinate of negative 1/2. So we take a look at all the points in here, and we say, okay, here's a point that has an x-coordinate of negative 1/2, and the reflection of that point across the x-axis also has an x-coordinate of negative 1/2. So what are the relevant angles? 4 pi over 3 and 2 pi over 3. So we can say that this implies that alpha can be either 2 pi over 3 or 4 pi over 3. Now what we need to do is to solve for theta using these values for alpha. So using the first alpha value, namely 2 pi over 3, we can say that we want to solve for theta. So using alpha equals 2 pi over 3, solve for theta. Now keep in mind that alpha was defined to be 2 times theta. So we have 2 times theta is equal to 2 pi over 3. The next thing we want to do is to divide both sides by 2. So we have the 2 theta divided by 2 is equal to the 2 pi over 3 divided by 2. Notice that the 2 cancel here and the 2's cancel there as well. So you get that theta is equal to pi over 3. And that is an angle on the given interval from 0 to 2 pi. So we're good. To generate the next angle, we need to pay close attention to the period. The period of secant of theta is equal to 2 pi. Now we're going to take that period and we're going to divide that by the absolute value of the coefficient of theta in the given function. Our given function involves a secant of 2 theta. So the coefficient of theta there is 2. So we're going to take the absolute value of that 2 and put it as the denominator here, so we can do the quotient and get the period of secant of 2 times theta. Well, absolute value of 2 is 2, so we have 2 pi divided by 2. So the period of that newly defined function is simply equal to pi. And why is that relevant? Because going back to this one, to generate the next angle, we're going to take theta to be pi over 3 plus the period of pi. And let's multiply that pi by 3 over 3 to get the common denominator. So the next angle happens to measure 4 pi over 3. Now using the other value of alpha, we can solve for theta. So using alpha to be the 4 pi over 3, we also need to solve for theta. So using the fact that alpha is 2 times theta, we have 2 times theta is equal to 4 pi over 3. Which means that after we divide both sides by 2, we get that theta happens to be equal to 2 pi over 3. Why is that the case? Because this 4 is 2 times 2, so one of those 2's cancel with this 2, and you just have 2 times pi divided by 3. So that's still an angle between 0 and 2 pi, so we're good in terms of the interval. To generate the next angle, we're going to add the previously defined period for our function. So we have theta is also 2 pi over 3 plus the period of pi. And that period of pi will be multiplied by 3 over 3 to get the common denominator. So we get that the next value for theta happens to be 2 pi plus 3 pi all over 3, which is 5 pi over 3. And that gives you the 4 values that happen to be a solution to the first original equation. So we can say that theta is equal to pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And those are all solutions between 0 and 2 pi to the originally defined equation. This concludes this video on how to solve trigonometric equations involving secant part 3. Thank you for watching and have a wonderful day.